Hello, and welcome back to Principles of Macroeconomics. I'm your host, Dr. B. Today we're going to be talking about elasticity. Before we jump into elasticity, in the classroom, for those of you who are having trouble accessing my UDC, please try to access it through Firefox. It seems to be the only web browser at the moment that is working properly. So please try to access the classroom through Firefox web browser. Uh, in the classroom, I do want to point out a couple of things to you in the Firefox web browser in the classroom. A couple of things I want to point out. First one is, if you still don't have access to the textbook, you really need to. All right. If you're still waiting on the bookstore, you're waiting on books, whatever, I got you covered. All right. And thank you again to Dario for finding this information for us. So under the Start Here menu, if you click on Course Textbook, go ahead and click on that second link. It'll open up a PDF version of the textbook. So don't worry about trying to get access to it. It's there. Okay. It's the same exact chapters. It's the first subset of chapters is what it's classified as. The chapter numbers might be a little different, but I promise you it's all the same textbook. Second housekeeping note, we are in week 4. So we covered weeks 1, 2, and 3 already. We're in week 4. Last week we had an awesome discussion. And yes, I wrote this discussion myself. So, that's why you may not have been exposed to it before. So in the chapter 4 discussion, which I thought was really cool, we looked at the shifts in supply and demand from the perspective of the pandemic. And we gave a couple of examples like used cars, computer chips for automobiles. It's such an interesting conversation. And we look at these real world examples of how we can apply what we're learning, right? And so that's why I thought that the chapter 4 discussion was so interesting and I read through a lot of your responses and I was fascinated with what some of you came up with. And it's just it's really just an interesting dynamic with the world that we're in now. And that conversation we had on supply and demand in chapter 4 discussion board, I thought was really awesome. And I hope you all enjoyed it as much as I did. I really enjoyed reading a lot of your responses. I updated the grades for the discussion today, so your grade book should be up to date. So that was last week. This week, we're going to be covering chapters 5 and 6. So 5 is on what we're talking about right now, which is elasticity. And 6, if I recall, it is supply and demand with government policy. That one's the shorter of the two. So let's go ahead and jump into that. And so for this chapter, you'll have the chapter 5 quiz. For chapter 6, you'll have chapter 6 homework, both of which are due, of course, Sunday night. So do your best to mind the due dates. And the reason for that is because when we approach the middle of the semester, you'll have your midterm exam, and that'll cover everything that we're covering through weeks 1 through 6, I believe it is. Okay, let's go ahead and jump into elasticity. What I want you to understand about elasticity before we jump into the content is the word elasticity stems from being elastic. When you hear the word elastic, think of like a rubber band. A rubber band is elastic, right? It's made out of elastic material. Elastic simply means it's able to stretch. Yeah. It's like my pants, throughout the pandemic. I have elastic pants now, right? Because gaining and losing weight. Elasticity, right? Elasticity from the term elastic simply means it's how much toleration there is within the economy. That's what elastic means. Think of like a rubber band going back and forth. It's elastic. It changes with with toleration levels. And that's what elasticity is. And there's a lot of applications of elasticity, and we'll talk a lot about those. So we'll discuss what is elasticity, what kind of issues help us to understand it, what is price elasticity related to the demand curve, which we discussed in the previous chapter, how it relates to revenue and expenses for a company, or to an economy or a government. What is the price elasticity of supply and demand? And there's a lot of really interesting concepts around elasticity that we'll discuss. And we'll also talk about more recent considerations of elasticity to give you some more current examples. So here's a scenario which I found kind of interesting is, let's say you design websites for local businesses. That's your business. You're a website designer, okay? But you as a website designer, you charge $200 per website design. And you design about 12 websites a month. Okay. So we can already understand what our revenue is. $200 per website, you design 12 per month. So if I whip out my calculator, 200 times 12, we're looking at $2,400 per month of revenue based off of your website design company. So looking at that, our costs are continuing to increase. So you're thinking about raising the price per website to $250. Now, if you do that, so $2,400 is what your current monthly income is. If you go 250 times the 12 websites, you're looking at $3,000. Okay, so it's a $500 revenue difference. 250 times 12 is 3,000. 200 times 12, 2,500. So you're looking at a $500 difference if you increase your per website to 250. Now, but there's some considerations, right? With respect to the law of demand. If you raise your price by $50 per website, you might have less customers wanting you to develop their website, right? It's like, oh, you raise your prices by $50. I don't know if I could afford that type of swing. That's what your customers will say. That's not always the case, but most of the time when the price goes up, less people want it. You know what I mean? It's the law of demand. So if that happens, how much would your revenue fall by, or might it go up? Well, of course, it depends. It depends on how many customers you get, right? So let's look at this through the concept of elasticity. Elasticity, as our introduction went, elasticity, I want you to think about it like a rubber band. Elasticity represents the responsiveness, the tolerance level, okay? That's what elasticity is. It represents tolerance or responsiveness. So think of a rubber band. The more you stretch that rubber band, the more tension you're causing, right? And if you pull it too hard, it will snap. That's a rubber band, right? And the looser it is, the more flexible it is, right? And the tighter it is, the less responsive it is. So that is how I want you to think of elasticity, like a rubber band. It's loose when it's nice and open, and then when you pull it, it becomes the tension goes up, right? It becomes tight. It works the same way in economics. So there's elasticity or responsiveness to change, right? And one of those changes is price. So if depending on the quantity of the demand of a good responds to a change in the price of that good. In other words, this measures the sensitivity of buyers to the price Okay. If the price goes up, buyers might be more sensitive to that. Depends on the product, right? There's some products that you just have to buy, like gasoline. It doesn't matter if gasoline is at $2.50 a gallon or $3.50 a gallon, you still need it to get from point A to point B. Okay, so that is the sensitivity is a little bit looser with something like gasoline. But if it's something like, um, I don't know, if it's something like pizza, you don't necessarily need pizza. If the price goes from $2 a slice to $3.50 a slice, there's a good chance you're going to be sensitive to that. You'll be like, oh, you know what? I guess I don't need pizza. I'll just go eat burgers or whatever, right? So it the concept of price elasticity is it's measuring your sensitivity to buying certain products, right? It's your sensitivity to the price. That's price elasticity. So if we look at it, the price elasticity of demand, this is the formula that you need to know for the price elasticity of demand. It's the percent change in the quantity demanded divided by the percent change in the price. Okay. Now, you might be asking yourself, well, Dr. B, it's been a while since I had to figure out how to calculate the percent change of anything, right? Well, here's how that works. And let me see if I can do this with the annotate. Okay. Hopefully you can all see this, but I'm going to start writing on the screen. Okay. I'm really bad at this. My handwriting's terrible. So if you can't read it, let me know. But here's the way to simplify this equation. That's a parenthesis. I know it looks like the letter C. It's a parenthesis. So it's the new. Oh my goodness, it's terrible. New. It's the new quantity. So P would be Q2 minus the old quantity Q1 divided by the old quantity. I know, right? Look at that terrible handwriting. So it's Q2 minus Q1 divided by Q1. Okay, make sure that so the reason, as you probably recall from a long time ago, order of operations, the PEMDAS, right? You do parentheses first. So quantity 2 minus quantity 1 divided by quantity 1. You do the minus first and then the division, because remember, anything in parentheses you do first. So that's how you find the percent change of anything. So it's the new minus the old divided by the old. And the change of percent change of quantity, it's Q2 minus Q1. You do that first, divided by Q1. That will get you the percent change in the quantity. Does that make sense? Or are there any questions so far? You can all hear me, yes?
Yeah, that makes sense.
All right. Thank you, Dario.
I get it, Dr. B.
All right. Thank you, Asia. Appreciate you. Okay. And it's the same exact concept with a percent change in price. So you go percent change in price would be P2 minus P1 divided by P1. It's a little bit better, right? And then you just make sure the parentheses, yeah? So that's how you find percent change in price. Now, once you find the percent change for both, you divide the percent change in quantity divided by the percent change in price. Now, as long as you do that, you'll be fine. Once you understand that formula, you got price elasticity of demand. You got it perfect. Okay. Now, it's interesting with the price elasticity because, as we had said earlier, price elasticity measures the tolerance. It measures the. I'm going to stop the annotate. It measures the tolerance, right? So, uh, P and Q move in opposite directions. Okay, so lower quantity, higher price. They move in opposite directions, which would make the price elasticity negative. Okay, so let's take a look at our website design company. So earlier we had said our, our current monthly is we charge $200 a month to design website, $200 per website, right? At $200 per website, we design 12 websites per month, putting us at about $2,500 of revenue per month. We're considering raising our prices to $250 per month because our costs have gone up. To cover our costs, we want to get some more revenue. Makes perfect sense. So in that, if we raise our prices to 250, we might only attract 8 total customers. So 8 websites at 250. So if that's the case, okay, 8 at 250, oh, sorry, 8 at 250, oh, you know, it helps if I do this right. 8 times 250 is 2,000. So that would result in a decrease in revenue by $2,000. Okay. This formula, this is exactly what I showed you earlier to find percent change, right? The new minus the old divided by old. It's the same exact concept, yes? So new, which is end value, minus start value, the old, divided by old start value. Multiply by 100 to get the percent, yeah? So, so we would do Q2 minus Q1 divided by Q1 times 100. P2 minus P1 divided by P1 times 100. Those get your percent changes. So percent change in the price, 250 minus 200 divided by 200 equals 25%. Change in the quantity, 12 minus 8, 12 minus, oh wait, I apologize. 8 minus 12 divided by 12 gets us minus 33%. 25% divided by, or I'm sorry, 25% divided by minus 33% would be a negative 1.33. So if we look at the 1.33, because we dropped the negative, shows us our price elasticity. And to drop the negative, you just switch the sides. So what we see here is when we let me see here. If we go from A to B, in other words, we're raising our prices, we see that the price elasticity is 1.33. If we go from B to A, the price elasticity is 2.5. How did that happen? Well, we're reversing it, right? So when we reverse it, the percent change in the price from B to A, 250 minus 200 is 50 divided by 250 would be minus 20%. And the change in quantity would be 8 minus 12 divided by 8, which would be 50%. So price elasticity 50 over 20 would be 2.5. So it just kind of shows you how it works the other direction. A to B, B to A. It's basically just working it backward. So the price elasticity of demand shows us the tolerance of price changes. And with that tolerance, it basically tells us at what point will customers be willing and able to buy, right? What price range, essentially. And that is important for us to understand because it helps us to find the middle ground. We call this the midpoint method. That middle ground in the midpoint method is the number halfway between the start and end values, which we consider to be the average of values, right? And so with the average of values, we can get a better understanding of where our customers would be most flexible with respect to price. That's why I call it the midpoint. So if we go look at our example, we have 12 websites at $200, right? And we would only have 8 at $250. So that tells me that I can probably go somewhere in between those two price points and still maintain a certain level of customers, right? And so that's how a lot of price decisions are made. Of course, we consider all of our costs to make that product, but how do we price it, right? When you price something in your business, let's say you own a boutique makeup business and you're trying to figure out how to price your products appropriately, you would definitely consider something like the price elasticity. What's the most someone's willing to buy it at? What's the least they're willing to buy it at, right? And understanding that and pricing it somewhere in between, very, very important, because you want to try to maximize your profit, but at the same time, maintain the same level of customers, right? And so that's what this midpoint kind of tells us in a way. So looking at the percent change for the midpoint, we have end value minus start value divided by midpoint. So let's break that down. So our end value, Q2 minus Q1 divided by Q2 minus Q1 plus Q1, right? End value. Our end value would be 250 minus start value 200 divided by midpoint 225. How do we get 225? Well, it's the midpoint between 250 and 200. And that would be most. That'd be the way to find midpoint for the price. You could also do the same thing for the quantity. So looking at the price elasticity of demand, and this second equation you see here, this is how we find the midpoint for quantity and price. Q2 minus Q1, do that first. Then divide by Q2 plus Q1 divided by 2. That helps us. That what they call it, the denominator shows us, or I'm sorry, is it the numerator or denominator? I always forget. The bottom part shows us that our base. That gets us our average, and the average is the midpoint, right? And we do that for both quantity and price. And so let's look at it from our example. So using the midpoint average for price, 250 minus 200 divided by 225. How we got 225? It's the midpoint between 250 and 200. Times 100 is 22.2%. Looking at the change in quantity, 12 minus 8 divided by 10. How 10? 10 is the midpoint between 12 and 8. Times 100 is 40%. 40% divided by 22.2 is 1.8. An elasticity of 1.8 is in with relevant range. Oh, sorry. Went a little too fast there. Okay. So this example is iPhones. Obviously, much older data because we know that the new iPhones are like what, $1,200 or whatever. Remember, this was copyright in 2018, so not that long ago, 4 years ago. The average iPhone cost was about $400-$600. Yeah, believe it or not, I know, right? It's amazing what inflation and time will do. Okay, so looking at the information, if the price of an iPhone is at $400, then I'll be able to sell 10,600 iPhones. If the price of an iPhone is at $600, I'll be able to sell 8,400. Using the midpoint method, let's calculate the changes. Okay. So percent change in price: 600 new minus 400 old divided by 500 midpoint times 100 is 40% change in price. Change in quantity demand: 10,600 minus 8,400 divided by 9,500. 9,500, that's our midpoint between 10,006 and 8,400. Divided by 9,500.
Dr. B,
Yes, please.
I have a question really quick. Can you remind me why it's times 100? What does the 100 represent?
Sure, that's how we get into a percentage.
Oh, okay, true. Okay.
Yeah, because otherwise it would be like point.
A big number.
Yeah, exactly. Yeah, it'd be like it'd be 0.4 or 0.2316. Yeah, yeah, exactly. Yeah, because to get from number to percentage, that's why we times 100. That's right. Yep. So percent change in quantity: 10,600 minus 8,400 divided by midpoint 9,500 times 100 is 23.16. 23.16 divided by 40 is 0.58. 0.58 would be our price elasticity. So in looking at these examples, understanding that price elasticity represents the tolerance level of which consumers are willing to buy a particular product within a certain price range represents price elasticity. The tighter the elastic band gets, the less willing people are willing to buy it. That's why I like to use the analogy of a rubber band, because it makes the most sense when we talk about something like price elasticity or elasticity in general. You do the same thing with quantity elasticity. Okay. So when we're talking about price, we typically want to compare goods to each other to kind of understand what an economy is doing. So in other words, we're applying it to the greater economy, not just a specific product. So let's say we got two products, and both of these products increased by 20%. Sales price rises by 20% for these two products. The highest price elasticity of demand would be based on the willingness of the consumers to buy either of the two products based on that change in price, elasticity in price. So let's take a look at this example. Two very different products. Again, the concept behind comparing two different products is to determine on an economic scale the price elasticity. So we got sunscreen and breakfast cereal. Two very obviously, hopefully that's obvious, very different products. So the price of both of these goods rise by 20%. Which good does the quantity drop the most? Good question. So breakfast cereal. Instead of people buying breakfast cereal, they can buy something like bananas, or they can buy something like other breakfast foods, granola, whatever, right? There's substitutes, there's close substitutes. So if the price rises on breakfast cereal, people will just substitute it for some other breakfast type of thing, right? But sunscreen, I mean, I don't know what else protects you from, I guess umbrellas, like people might buy umbrellas, but I mean, that's kind of, I would think that would cost more than sunscreen, right? So there's not really a good substitute for sunscreen. Um, so if the price increases on sunscreen, demand won't be too much affected because there's no close substitute. If I can't substitute something, which means I basically have to buy it, the demand's not going to change. So it's kind of like saying breakfast and motor oil. You need motor oil. I mean, you can't go without it, and there is no substitute for it. So you got to pay the extra 20%. But with breakfast cereal, I could easily go to a different product. So the price goes up. Yeah, I'm not going to buy that. I'm going to buy something else. So that's what this tells us. So the price elasticity is higher when there are other close substitutes available. In other words, the price elasticity in this example would be much higher for breakfast cereal than it would be for sunscreen. And that's simply because there are close comparables. Blue jeans and clothing. If the price goes up by 20%, which one would be affected the most in terms of quantity demanded? Well, it's a good question because blue jeans is technically clothing, right? And there are quite a few substitutes. So the answer for this one is because they're narrowly defined. It would be a little hard to tell, but the price elasticity would actually be high for both of them. Insulin and yachts. Well, there's no substitute for insulin, and there are for yachts. So the price elasticity would be higher for luxury goods. Yeah. Gasoline. In the short run and long run. Okay. So I was hoping we were going to get to gasoline at some point. So gasoline, there's no substitute in the short run. In other words, you can ride a bus or a carpool in the short run, but the reality is the demand is not going to go down by much. In the long run, people might buy electric cars. They might move closer to work. So it depends in the long and short run. Price elasticity is always going to be higher in the long run. And the reason for that is ultimately there will be a substitute option to gasoline vehicles, right? In the long run, you could buy an electric car, you can walk, live closer to work. So therefore the demand would be lower in the long run, which means price elasticity would be higher. So let's think about the demand curve. As you recall, the demand curve is downward sloping and to the right. And thinking about demand is elastic if the price elasticity is greater than 1. Demand is inelastic if the elasticity is less than 1. And demand has unit elasticity if the demand is equal to 1. So what this tells us is with price elasticity greater than 1, we call that elastic. It's elastic. It's inelastic if it's less than 1. And it's unit elastic if it's the same as 1. So remember, elasticity, think of the rubber band, right? It's the tolerance level. Inelasticity means there is no tolerance, right? So that's why if it's less than 1, there's no tolerance. If it's greater than 1, there's tolerance. So price elasticity of demand is equal to 0, and the demand curve is vertical if there's what we call perfect inelastic. Perfect inelastic rarely ever happens, but it's just something I need to tell you about, because if something is perfectly inelastic, it's 0. If it's perfectly elastic, it's infinity, which means the demand curve just continues horizontally. And if there's a greater price, the greater the price elasticity of demand, if the flatter the curve is. So this concept is it's weird because it almost never happens this way, right? This is the reason why this exists is in economics is to kind of benchmark everything, right? It's almost like saying, oh, the perfect world example. Well, there is no such thing as that, but this helps us to provide a benchmark. So if the percent change in the quantity demand is 0, we would expect a direct correlation to the change in price, but we would call this perfectly inelastic. It's perfectly inelastic if the demand change is 0. So the demand curve would be horizontal. There would be no price sensitivity, and elasticity is 0. If the price elasticity of demand is at a curve and it's downward sloping to the right sharply, we would consider that inelastic demand. Now remember, inelastic means the change, or the tolerance, the elasticity is less than 1. That means the consumer price sensitivity is relatively low. In most cases, gasoline, for example, is relatively inelastic demand, because the price goes up 20 cents a gallon. That's a very low change in the price in comparison, because there is no real alternative, right? So therefore, it will be relatively low elasticity, less than 1. Less than 1 inelastic, greater than 1 elastic. Now, unit elastic is where it equals 1. If the change equals 1, we call it unit elastic. And the only way it equals 1 is if the percent change in quantity divided by the percent change in price equals 1. And in that case, it's unit elastic. And we see that the consumer price sensitivity is considered intermediate. What that means is it's temporary. So that temporary price sensitivity is typically a result of a change in the marketplace that is abrupt and then smooths out over time. An example of this would be toilet paper, okay, during the pandemic. Toilet paper before the pandemic, the price was relatively constant, right? It's like $2 for a pack, we'll say. And then the pandemic hits, all of a sudden it's $10 a pack, right? So that is unit elastic. It is an immediate, abrupt change, and then it steadies out over time. So that would be a unit elastic situation, and it's relatively temporary over time. Now, elastic demand is something that's greater than 1. If it's greater than 1, it's relatively high consumer price sensitivity, and the demand curve is also relatively flat. An example of something that would be elastic with respect to demand would be something like, I guess the earlier example we gave is cereal. That is definitely elastic demand. If the price jumps in cereal, chances are demand will go down sharply. because there are substitutes to that product. It's like saying, let's say the price of hot dogs skyrockets, okay, for whatever reason. So the price of hot dogs goes crazy high. Well, that will be elastic demand. People will simply shift away from eating hot dogs and go toward eating something else like hamburgers, right? So that represents elasticity. If something is perfectly elastic, which again never happens, but it's where the price doesn't change over time, uh, and the demand stays the same over time. We call that perfectly elastic. Again, it's a perfect world situation, but it never happens. And the consumer price sensitivity to that is extreme, and it lasts forever. Again, there's no real perfect elastic situation. So, okay, so this is some more real world examples. Price of eggs has elasticity of 0.1. So typically what that means is if the price goes up on eggs, people still buy them. Reason why they'll buy them is there's no real substitute for eggs. Same with milk. Yeah. Eggs and milk. You need them for baking things. You need them for breakfast. You need them for whatever. Eggs and milk are found in pretty much everything. So it's hard to substitute those because there really is no true substitute. That's why elasticity is very low. Healthcare, again, very low. You can't replace it. Cigarettes, yeah, because if you're addicted to nicotine, it doesn't matter if the price skyrockets. You'll still use them. Rice, rice is in a ton of different ingredients, a ton of different recipes. Elasticity is very low. Housing, we all need it. There is some sensitivity to it though at 0.7, but it's still inelastic because you need housing. I mean, everyone does. Yeah. Beef, 1.6. You can substitute beef for poultry. Yeah. So that's why the elasticity is above 1. It's elastic. It's above 1. Elastic above 1. Inelastic below 1. Peanut butter, 1.7. You can substitute that for jelly or whatever. Restaurant meals, high elasticity, 2.3. Mountain Dew, 4.4. So, the more luxury goods have very high elasticity. Things that are necessities have very low elasticity. That's basically what this scale represents. So as we know, demand curves are downward sloping and to the right. With a linear demand curve, if it's constant, its elasticity may not be constant. Okay. Here's a couple of price point changes and quantity changes. From $30 to $20, 30 minus 20 divided by 20, because the percent change divided by 40%, representing the average, gets us 5. 5. 5 is very high on the elasticity scale, so it's very elastic. 67% divided by 67% equals 1. That means it's unit elastic. 40% divided by 200% is 0.2. That is inelastic. Now for the fun part. You all understand elasticity for the most part, right? It's a more basic concept.
It's
I
kind of
think for the
confused
most
there.
part, it's
For the most part?
I just need practice.
right. I'm with Dario.
Yep.
Yeah. I'm gonna look at this video, multiple times. Go over it multiple times.
Sounds good, Joven. Yeah, it does take a lot of practice, and there's a ton of different example problems out there. But once you understand the basic formulas, right, and the what is elastic, unit elastic, inelastic, or just and it's as simple as remembering that one and above, or I'm sorry, above one is elastic, equal to one is unit elastic, and anything below one is inelastic. And I do want to quickly go back and I'll just kind of help you a little bit further with this part is when we understanding the basic formula. The basic formula for the elasticity of demand, percent change in the quantity demand divided by the percent change in price. Once you understand that, it becomes relatively, I don't want to say simple, but easier to understand the concept of how to calculate the elasticity. So percent change, remember, it's the new price point or the new quantity minus the old quantity. So Q2 minus Q1 divided by Q1. That gets you percent change in quantity. And the same concept goes for percent change in price. P2 minus P1 divided by P1 gets you the percent change in price. And once you have that very concept down, you'll be okay. Because that'll lay the foundation for elasticity, for everything we do in elasticity. And then what we talked about just now is with an elasticity greater than 1, it's elastic. Equal to 1, it's unit elastic. And less than 1, it's inelastic. So let's apply this concept to revenue. As you hopefully know, and if you don't know, I'll tell you, revenue is earned by sales. Your company sells, it earns revenue. Yeah? Sales is revenue. Sales is revenue. Revenue is what is the business generates, and they use revenue to pay bills, to expand, to invest, all of those good things. That's what revenue helps a business do. So let's take a look at how we can apply price elasticity to total revenue. Total revenue is simply the sales price, P, times the quantity sold, Q. P times price times quantity equals total revenue. The number of units I sold times the price I sold them at. That gives me my total revenue. Very basic, simple to understand. Every business follows this extremely basic principle. Price of what I sell it at times the quantity I've sold. That's my total revenue. When a price increases, it has two possible effects on total revenue. Will yield higher revenue if the price is higher? Sure. Yes. I'll earn more revenue with a higher price. But with a higher price, I'll probably sell less. So, I'll earn higher revenue because the price is higher. But with a higher sales price, the other possibility is true. I'll sell less units. Okay, that's basic law supply law of demand, right? Basic law of demand. if I raise my prices, I'm going to sell less because people will want less at a higher price. Yeah. So which impact is bigger? Well, it depends. Depends on the price elasticity. So if the elasticity is greater than 1%, change, if the elasticity is greater than 1%, if the percent change in the quantity is greater than the percent change in price. So if change in quantity is greater than change in price, my elasticity will be greater than 1%. The reason for that is if I'm changing the quantity that I'm selling, and that change in the quantity is greater than the change in the price, that means that it'll be price elastic. In other words, they're more sensitive to the quantity rather than the price. So the elasticity will be greater than 1 if the change in quantity is greater than the change in price. The total revenue will decrease if there's a price increase when there is a fall in revenue lower than the from the lower quantity. So if my quantity decreases, right, which I would expect to do if I raise prices, then I'll have less. I'll have less total revenue because I'm selling less because my prices went up. That's what that tells us. Now, if the pricing, and that's when it's elastic, right? Because elasticity, I'm going to buy less if the sales price is higher. That's elastic. I'm sensitive to that price increase. That's what elasticity is. I'm sensitive to the price increase. Elasticity is measuring my sensitivity to the change in price. If it's inelastic and the price goes up, this is when elasticity is less than 1. The percent change in the quantity demanded is less than the percent change in the price. My total revenue will increase. The lower revenue from the lower quantity increases my total revenue from a higher price. So I'm going to be less sensitive to that change, and that's like gasoline, for example. So looking at our earlier example, we're a website designer, right? So if we're a website designer, my elasticity for demand is 1.8. At price point 1 of $200 and a quantity of 12 websites gets me my revenue 24. 2,400. If my price rises to 250, I'll sell 8 websites, which means my revenue dropped to 2,000. So I'm selling less, although my prices are higher, but I'm selling less because my prices went up. Yeah. So I got more revenue, but I got less customers. So, in terms of demand anyway. So the point here is that with this change in price, I'm going to sell less if my prices go up. And my price is relatively inelastic at $200 per website at 12 websites per month. It's inelastic, relatively inelastic at that price. And the reason being is they're not as sensitive at that price. At a higher price, they are more sensitive, which means I'll have a higher elasticity. So elasticity at 1.8, which is the average, it's pretty good. It's right in between. So at $200, selling 12 and a revenue of 2,400, relatively inelastic. 250 at 10 websites would give me 2,500 in revenue. That would be a good case scenario. But earlier, the possibility is if I raise it to 250, I would only get 8 customers. If I only got 8 customers, that would put me at 2,000, right? So that would be loss. If I raise it to 250 and I get 10 customers, it's 2,500, which is obviously $100 better than the inelastic price. So in looking at that example, you can see how small changes in your pricing strategy will have a massive impact on your customers' sensitivity to those price changes. Okay, let's go through. Oh, I like this one. Yeah, let's look at B. B is a good one. Okay. Cruise lines. Let's say we got Carnival and Norwegian. Carnival and whatever the other big one is there. Let's do Norwegian, I guess. So we got Carnival, Norwegian, the cruise companies. As a result of a fare war, you can do the same thing with airlines, I guess. The price of a luxury cruise falls by 20%. A fare war simply means that two companies are competing very strongly with each other to reduce prices to get more customers, right? And so they compete heavily in price. Causes what we call a fare war. It's where they compete very strategically with each other in terms of price. What happens to the tolls company revenue if with a result of a 20% decrease in fares? So look, knowing that revenue equals price times quantity, we would recognize the fall in price, but the quantity increases, which will increase revenue. Makes perfect sense. Since the demand is elastic, we know elastic demand for cruise ships, yeah? I mean, there's obvious substitutes. The quantity will increase more than 20%, so revenues will increase. Okay, there's so many different ways of understanding elasticity as it relates to other social economic factors like drug-related crime, going up and down based off of the demand, right? And it really is applicable to any situation where there's an economic transaction. And so we can see that through that example. Policy changes impact pretty much everything, right? From an economic perspective. The more policy changes are introduced, the greater the impact, which causes shifts in demand. And that can be really said with any type of economy, whether it's legal or not. The price elasticity of supply. So we talked about price elasticity of demand. Now, of course, we got to talk about supply. Can't talk about demand without supply. Price elasticity of supply represents the quantity supplied as a response to the change in the price. So the percent change in the quantity supplied is divided by the percent change in price. This gives us elasticity of supply. So if the price goes up, we would expect an increase in the quantity. So percent change in quantity divided by the percent change in price. And yes, it works the same exact way. So it would be Q2 minus Q1 divided by Q1 gets you the percent change in quantity. And then you do the same thing get this percent change in price. So it'd be P2 minus P1 divided by P1 to get the percent change in price. Because remember, to get the percent change of anything, it's the new minus old divided by old. It's percent change. Oh, and then of course multiply by 100. Don't forget that part. Price elasticity of supply. If it works the same exact way, right? So it's unit elastic if it's equal to 1. It's elastic if it's greater than 1. It's inelastic if it's less than. Works the same way as demand. Price elasticity of supply and demand are very similar. They work in tandem. If it's perfectly inelastic if it equals 0. So instead of 1, it's 0 on the supply side. It's perfectly elastic if price elasticity of supply is infinite. And a flat supply curve represents the shift in price. So if there is no change in the supply and there's a change in price, we consider this to be perfectly inelastic. It's vertical, price goes up, there's no sensitivity. If there is inelastic supply, which is less than 1, this sensitivity is relatively low and is steep. Price elasticity of supply, if it's unit elastic, means it's 1, then it's intermediate and there's an intermediate slope. If it's elastic, which means greater than 1, we expect sensitivity to be relatively high. So again, very, very, very similar to demand elasticity. Demand elasticity and supply elasticity are very similar in nature. Which is why it almost looks like this slide's almost the exact same, right? Because they are so close. The determinants of supply, greater the price of supply, it's easier for sellers to change quantity that they produce. So, I could always produce less or more, depending on where the demand is at. It's in the long run, firms can always build new factories and be able to enter new markets. On the short side of things, the change is, you could shift how much you're producing. So here's an example: beachfront property. Oh, that sounds nice. It's inelastic. Obviously, you don't need to live on the beach, although we want to. Supply of new cars is relatively elastic. If the population growth causes demand of both goods to double, which would be produced the most? Excellent question. Looking at both, we can see the impact between A and B. Supply of new cars versus the supply of housing. So remember, if it's less than 1, it's inelastic. If it equals 1, it's unit elastic. Greater than 1, elastic. What happened here? Okay, here we go. It's kind of weird. Depending on the quantity demanded, there may be a respective change based on the consumer's income. Your income goes up, typically the quantity demanded goes up. Normal, very normal concept. The opposite is also true. Percent change in quantity demanded divided by the percent change in income. Normal goods, if the income elasticity is greater than 0, customers will buy normal goods. If the income elasticity is less than 0, they will buy what we call inferior goods. A way to think about that is if your change in income is greater than 0, you'll buy the name brand clothing. If your change in income is less than 0, you'll buy the generic brand clothing. Right? That's the way of thinking about how the change in income relates to the types of goods that people buy. That's the way I think of it anyway. But this is one example. Cross price elasticity. When the quantity demand of a good responds to the change in the price of another good, percent change in of the quantity of the first good is divided by the percent change in the price of the second good. We call these substitutes and complements. A substitute is just that. It switches out with another product. A complement is in addition to or is related to a product. A substitute would be hot dogs for hamburgers. A complement would be ketchup and relish. That's kind of the best application we got. Okay, let's see. We're almost there with this one. Let's go through that. We kind of beat that up, didn't we? Okay, OPEC. Most of you probably know what OPEC is. If you don't, these are the oil producing economic countries. OPEC, oil producing economic, something like that, right? Basically, what it is it's a cartel that runs the prices of oil throughout the world. As you probably know, the vast majority of oil produced in the planet is only by a few countries, and those countries get together in a meeting and they set prices on oil. That's what OPEC is, and that's why oil prices are always typically high, because they are controlled by a small group. And maybe someday that'll change, but probably not in our lifetime. Okay, we made it through elasticity. Any additional questions on elasticity? Are you all okay?
Yes, we fine.
Okay.
Yeah.
I figure you're either sleeping, eating, or what. It's like 6:30. So, okay.
Watch it, but I have a question really quick, Professor B, because I know you said we're doing chapter 5 and 6 this week.
Yes, ma'am.
So this was just chapter 5 on
It's just chapter 5. Chapter 6 is a lot shorter.
Okay.
A lot shorter. Because it's all on government policy. It's very, very straightforward. So, what are your all thoughts? Do you want to cover? Well, I don't know if I can. Well, man, it'll be tight. We can get through the next chapter in 10 minutes, maybe 15 at the most. Because I know some of you either have another class or you're exhausted. So we could either get through it the next 15 minutes, or we could cover it on Wednesday. My vote's to do it in the next 15 minutes because it's really short, but it's up to y'all. Do you want to stick with me for 15 minutes and cover it? It'll be recorded either way. Otherwise, we'll meet on Wednesday for like 20 minutes.
I'd rather cover it now.
Yeah, same here.
You want to do it now?
Yeah.
All right, we'll do it now.
Agree.
And it'll be recorded, so if y'all need to miss part of it or whatever, it's okay. It'll be recorded. But okay, let me stop this recording and I'll start the next one.